Hey everybody, this is Reed from Chehalis Skies Aviation and welcome to a series I'm calling Aviation Knowledge. This video series will cover some of the ground knowledge related to the Private Pilot Certificate. This is designed for any aspiring pilots or anyone interested in aviation. My goal is to provide informative and engaging videos, so feel free to leave suggestions or comments to make this the best it can be. For today's lesson, we are going to be talking about the four forces of flight, but to start, we have to talk about some terms related to the four forces first. So, let's get started. Alrighty, so the first thing we're going to be talking about today is what is a force? After all, to understand the four forces of flight, you need to know what a force is. So, a force is an interaction that results in the movement of an object, unless that interaction is canceled out by another force. So you can think of a force as a push or a pull. Using our example here, you can see that Kevin has thrown this little ball. He has exerted a force by pushing, aka throwing, the ball displayed, and you can see that force is displayed by this white arrow right here. One thing to note is that a force has what's called a magnitude and direction. So magnitude is just a fancy word to describe how much. It's a number that represents how much force, in this instance, Kevin exerted on the ball. One thing to note is that a force has what's called a magnitude and direction. Magnitude is just a fancy word to describe how much. In this case, it's used to describe how much force Kevin exerts when he's throwing this ball. The magnitude of force is usually measured in what's called a newton. However, we won't be doing any math regarding forces, so we just need to understand the concept of magnitude and what it represents. A force also has a direction. This direction can be up, down, left, right, north, east, or any other direction in space. So, now that we know what a force is, let's talk about another concept called Newton's laws of motion. These laws explain how objects move and the way forces interact with objects. The first law is the law of inertia, stating an object at rest will remain at rest unless acted on by an outside force. In summary, an object won't move unless force is applied, and an object already moving won't change its speed or direction unless a force is applied. As an example, those dirty dishes that you leave in the sink, they're not going to magically move or clean themselves. A force must be applied to make that happen, also known as you doing the dishes. But enough of that. That is the first law of motion. The second law of motion explains how mass, acceleration, and force are related. We use the following equation, F equals m times a, or force equals mass times acceleration, to represent this. We use the equation to understand how acceleration is typically affected by these variables. The more mass or material you have, the more force it will take to accelerate it. So again, as an example, it's a lot easier to throw something like a baseball up to 60 miles an hour than it would be to try and throw a brick up to 60 miles an hour. The difference being baseball has a lot less mass than a brick does. Finally, the third law states, for every action there is an equal and opposite reaction. This idea is used in multiple different areas that I will talk about in the future, and is very important when we're talking about aviation. So to give an example of all of these three laws in action, we're going to use our drawing here of Kevin and the ball to explain all three. So for the first law of motion, we are going to think of it as before Kevin actually throws this ball or baseball. So Kevin has this ball just in his hand. He has not thrown it yet. It is demonstrating the law of inertia. That ball that's sitting in the palm of his hand is not going to start moving unless he pushes or pulls on that ball. So if he just tries to think in his brain and tell it to move, or is talking and trying to get it to move, nothing's going to happen because he's not pushing or pulling it. He has to provide that push or pull or that force to get it to move. The second law can be seen when we talk about him throwing two different objects of different mass. So let's use the example of that brick earlier. So when we're talking about this brick, and we're talking about him throwing these two objects, let's assume that Kevin is putting the same amount of force or effort into throwing it. So he's not throwing one harder than the other, they're throwing at the exact same force. What's going to happen is that the acceleration of this baseball might be 10 miles per hour per second, meaning that it is increasing 10 miles per hour every second. But if we talk about the brick with that same amount of force, because it has so much more mass, that brick is only accelerating at 2 miles per hour per second. So it's accelerating a lot slower, resulting in the brick ending up at a slower speed than the baseball would when he throws it. So moving on to our third and final law, we'll use another little snippet of our example here. And let's pretend that Kevin throws his baseball and there is a wall in the distance. So what happens is when Kevin throws this ball, the ball is going to start traveling towards the wall. Another example of inertia, the first law, would be that this ball is going to continue at that speed in that straight line distance unless acted on by another force. And in here, it's going to be acted on by a force by this wall. And the way that the wall is going to enact a force on the baseball is because of Newton's third law. So Newton's third law states that for every action, there's an equal and opposite reaction. So when this ball ends up impacting the wall, it's going to apply a force on the wall. So all that force that we put into that baseball is going to be transferred to the wall. But what happens is as it's transferred to the wall provides that force back on the ball in the opposite direction as displayed up here by this white arrow. And what that does is that ends up causing the ball to bounce off the wall in the opposite direction. Another way you could think of or experiment with this concept of the third law is if you were to take your hand and either on a desk or a wall, if you just push on that desk or wall, that feeling you get of pressing is actually that desk or wall pushing back on your hand. So it's not the force of you pushing the desk, it's the desk pushing back on you because of that third law. Alrighty, before we continue on to the four forces of flight, I want to provide another example of a force that doesn't necessarily involve two things touching physically. So that example we're going to use is the force of gravity. So you can have a force that is something not directly pushing or pulling with physical contact, like in the instance of gravity. Gravity is going to be pulling the ball down after it bounces off the wall. It's not physically touching it, this is just a force that exists as part of the universe. So that force is going to be put on the ball, causing the ball to fall towards the ground after the wall. So let's continue on now to talk about the four forces of flight, the main topic for today. Alright, so now let's talk about the four forces of flight. So we have a diagram here of an aircraft and the four forces surrounding it. There's an upwards force, downwards force, forwards force, and rearward force. So the reason we are going to talk about these four forces and why they're important is these forces are what we manipulate as pilots to change what the airplane does. So if you want to climb, descend, go faster, go slower, that's all going to be done by manipulating these four forces. So the names of the four forces are as follows. You've got lift, weight, thrust, and drag. So starting off, lift is going to be our upwards force. This force is going to be generated by the wing of the aircraft. This is what allows us to fly. This is what climbs us up into the sky. The next force is weight. And weight is a result of gravity. So weight exists because gravity exists, and it always is going to be in the direction towards the center of the Earth, or the ground. So no matter what orientation the plane's in, if the nose is pointed up, down, if the plane's upside down, right side up, turning, weight and the force of weight is always going to be towards the ground, towards the center of the Earth. So that's lift and weight. These guys oppose each other, so they're opposites. And then we also have thrust and drag, which are opposites. So thrust is the forwards force. With our aircraft, thrust is provided by the propeller. It's what propels us forward. See what I did there? The way it propels us forward is by using Newton's third law. There it is again. So Newton's third law acts in this way to produce thrust for us. So the propeller, when it's spinning, blows air towards the rear of the plane. So that's air blowing towards the rear of the plane. As a result, with that equal and opposite reaction, we get a large force that pushes us forward. So all that air, all the energy of that air going backwards is put into an opposite force going forwards, which pushes us forwards. So that's thrust. Now, the last force we're going to talk about is the force of drag. So the force of drag is usually split into two categories with different types of drag in each of those categories. But for today's lesson, we are just going to cover an overview of drag. We'll talk about it more in depth in another video. But you can think of drag as the opposite of thrust and is typically a result of things like friction and aerodynamic resistance. So when you are flying, you're going to be creating friction with the air you're going through. So it's going to start to try and slow you down, resulting in drag. So those are our four forces of flight. We've got lift, weight, thrust, and drag. Just to summarize, lift is created by the wing, is in the upwards direction. The opposing force is weight, generated by gravity. And then we have thrust, which is generated by our propeller because of Newton's third law. And then the opposite of thrust is drag, which is a result of things like friction and air resistance. So let's talk about now how these can be affected in flight, or you can use this knowledge to apply to flying your aircraft physically. Well, to fly, we have to change these forces. So let's say we wanted to take off out of Chehalis Airport and fly up for just a fun evening around the area to go sightseeing. So we're lined up on the runway, we're stationary. How are we going to get to the point of flying? Well, when we're stationary, thrust and drag are equal. So there is no thrust and there is no drag, in that they're equal, so we're sitting still. So to get going, we're going to have to increase thrust to overcome drag. There is no drag at this moment, so as we increase thrust, we're going to start moving. So we want that thrust to be a large force and that drag to be less than that. So as our thrust is larger than our drag, we're going to start to accelerate, start to get faster as we roll down the runway. Once we get to our takeoff speed, we're going to slightly raise the nose of the aircraft. What that's going to do is that's going to increase our lift force. It's going to be larger than the force of weight, and at that point, that is when the plane begins to fly and climb away from the ground. So as we're climbing, let's say we have the same amount of thrust in, but at some point, that thrust is going to stabilize with the drag, because as we get faster and faster, drag is going to increase more and more, and there's going to be a time when thrust is going to equal drag, and at that point we're going to stop increasing speed and we'll be at a constant speed as we climb. So those are just some examples of how you could manipulate these forces kind of in your mind when you're thinking about how to fly or what you're trying to do. So if you're trying to make the plane speed up, you have to understand that you need more thrust or you need less drag. If you're trying to climb, you need either more lift or less weight. Obviously, if you're actually flying, you're not going to really be able to change your less weight, so you would have to increase your lift. But that is how we think about these forces and how we manipulate them and understand how to get the plane to maneuver how we want it to. The last thing I want to cover on these four forces is a term we call unaccelerated straight and level flight. I'll try and spell that here for you. Straight and level flight. So, what this term means is that we are in a flying condition where we're not accelerating, so we're not increasing speed or decreasing speed, and we're straight and level. We're not climbing or getting higher or descending and getting lower. So to get this condition, we have to make sure that each of these opposing forces are equal to one another. So I'm just going to give some random values to demonstrate this, but let's say lift has a value of 8. To get our straight and level portion of the flying, weight must be 8. So these forces must be both 8, and that's how we know we're straight and level. We're not climbing or descending. To make sure we're not accelerating, thrust and drag have to be the same. So let's say we have a thrust of just 10, whatever force or number that really may be. As an example, use 10, and drag is also 10. At that point, thrust and drag are equal, so we're not going to be getting faster or slowing down. So your airspeed indicator, similar to a speedometer, is going to show a steady speed. One thing to note here, and that is something that's very common in the knowledge test for your private pilot license, is seeing a question with a statement asking true or false. And that statement would be, for unaccelerated straight and level flight, all forces must be equal. And that is a false statement. And you can see that here by how I wrote this as an example. It only has to be that lift and weight are equal, and that thrust and drag are equal. They could all be equal, and it would still be unaccelerated straight and level flight, but the minimum requirement is these two are equal, and these two are equal. As you can see, they have different values. So that is a little tricky question we'll try and get you on. But that's going to conclude today's discussion on the four forces of flight with the concepts of forces and Newton's 3 laws of motion. I hope you enjoyed our little video today. And if you have any suggestions or want to leave a like or let me know if this is something you guys are interested in, please do. But for now, I will see you next time. Have a good one.